Whoa! Thanks to the arrival of electric planes, it's time to clean the skies. How has this changed the world of aviation? Let's see if the sky is the limit. Hi everyone! In today's video, we'll look into the technology race for 100% electric planes. But before we begin, consider subscribing to my channel and smash the bell icon to get tuned. Done. Let's go! Electric aircraft are now the future of aviation. Unlike the drones that are currently being developed, the objective of the electrification of aircraft is to achieve greater performance, energy management, and speed. In recent months, numerous companies have announced that they are working on some type of electric aircraft, with more than 200 projects around the world at the end of 2019 that have already carried out some real flight tests. These developments are due to the need to reduce polluting emissions and the search for new forms of sustainable urban transport, which is why they tend to focus on small, fully electric low-capacity aircraft for use as air taxis or high-mobility vehicles, and on regional aircraft with capacities of about 15 people for short-haul trips. In this context, Airbus has partnered with other technology companies to carry out the development of several projects focused on promoting the electric mobility of aircraft. Among them, Vahana and Airbus stand out, which are 100% electric, are equipped with batteries, and intend to unseat the autonomous car within cities shortly. While Vahana is designed for a single passenger, Airbus has 4 seats to optimize travel and not saturate the airspace. Another of Airbus' most important projects in this area is the one known as X, whose purpose is the development of an aerial demonstrator in which one of its engines has been replaced by a 2 MW fully electric turbofan. This engine is powered by an electrical generation system and batteries, which can work simultaneously in those cases in which maximum thrust is needed, such as aircraft takeoff. Within this area of continuous research and development, Spain occupies a privileged position as it has numerous aeronautical companies involved in these projects, which guarantees the technological and economic growth of the country. The Spanish aeronautical industry has great interest from the general public, as it is considered one of the most technologically advanced. The growth forecasts for this sector are being supported by the increase in aircraft orders for the coming years, especially in civil aviation. However, given such growth, it is necessary to develop new technologies that reduce the emission of polluting gases to meet the environmental objectives set by the aerospace sector. So the development of these new electric or hybrid aircraft is essential in the short-medium term. The Air Race E, a competition for 100% electric aircraft that will start next year, will feature the Racer E, an aircraft designed to reach a maximum speed of 482 kmph with a continuous power of 150 kilowatts powered by lithium batteries. A few weekends ago, Dubai hosted the presentation of what is so far the only electric plane in the world to reach 450 kmph. Great news for commercial aviation, which wants, through electricity, to stop being the direct cause of 2% of greenhouse gas emissions, the data from the International Civil Aviation Organization. To develop electric propulsion in aircraft, Airbus, the University of Nottingham in the UK, and air race promoter Jep Zaltman have partnered by presenting the first team that will compete in the 2020 air race at the Dubai Air Show E, a competition for 100% electric aircraft. Electric planes are the future of aviation, but engineers still have to overcome some problems. What might electric planes look like in the future? The tickets would be €23, the quieter airports, or even much shorter runways. Companies have opted for battery-powered aircraft for a cleaner future. But although electric planes have been around since the 1970s, they have never gotten off the ground. What is it that keeps them grounded? In the late 1800s, 2 French army officers experimented with electricity to power an aircraft, but ran into problems when the battery was unable to hold enough power. This would become a very common problem for the next 100 years. When nickel-cadmium batteries were invented, the first electric-powered flight took off, but the flight lasted less than 15 minutes. Later, in the 1980s, lithium-ion batteries were invented. They could store more energy than ever before, leading to the construction of planes like the Solar Impulse 2. Starting in 2015, The solar-powered plane spent 16 months flying around the world, only flying at an average speed of 45 to 55 km/h. Solar Impulse is part of a movement that has emerged in recent years to develop alternative energy sources, especially as people and governments began to realize how bad flying was for the environment. The aviation industry emitted close to 1 billion tons of CO2 in 2019 alone. That's around 2.5% of global emissions. It may not sound like much, but it is almost as much as the entire continent of South America emits in a year. We have to make changes in the industry, and electrification is one of the big trends that we hope will reduce that amount of CO2. Electric planes have been on people's minds for a while, but two big problems continue to keep this idea at a standstill. First, the technology is not quite ready. When you're trying to get an electric plane off the ground, what you need is a battery that packs a lot of punch and fits into a small package, but batteries are not as efficient as fuel and probably won't be for a while. A battery's efficiency, or the ability to hold that energy, is measured in specific energy. Right now, even the best batteries have a specific energy of only 250 watt-hours per kilogram, but we have to get closer to 800 before we can start flying. And that's still far compared to the specific energy of jet fuel, which is nearly 12,000 watt-hours per kilogram. Remember those computers from the 80s? They were huge but much less powerful than the fancy computers we have today. Right now, batteries are like those computers from the 1980s. They're not as powerful as we need them to be. And not only are they big, but they're also very heavy. So if you want to add more power to an airplane, you need to get a bigger battery. And to get the plane to take off despite the weight, you'll need an even bigger battery that's more powerful, but that means more weight. And then, you'll need an even bigger battery to make up for that weight. You already understand the crux of the matter. But even if engineers do manage to design such a plane, because of the shortcomings of battery technology, they have to face the industry's second hurdle: certification. In the United States, that means you have to get permission from the Federal Aviation Administration to test and fly an electric plane. Companies have to prove that every inch of their plane is safe by passing a series of tests, one of which involves making sure the battery cells don't catch fire. Every electric plane in development is different, but they all have one thing in common: they're after flights under 500 miles. And while that may not sound like an impressive distance, these short-range electric planes could solve a major travel problem. What do you look for in a 100% electric aircraft? Unlike drones currently being developed, the goal of electrifying aircraft is to achieve greater performance, power management, and speed. On the other hand, in addition to Airbus, other companies such as Siemens or Rolls-Royce are already competing in the technological race to achieve cutting-edge electric aircraft that have the same operation as conventional aircraft based on fossil fuels. Also, countries like Norway have expressed their intention to create a 100% electric fleet of aircraft, 100% electric plane E-Racer. The E-Racer electric plane tested in Dubai is capable of reaching a top speed of 482 km/h thanks to its 150 kilowatts continuous power supplied by lithium batteries that are attached under the fuselage. The estimated flight time, depending on the power demanded, is between 5 and 10 minutes. The aircraft has been developed under the Beacons of Excellence program, in which the University of Nottingham has invested an amount of 13 million euros. Although advances in aircraft electrification are very optimistic, the units manufactured are still light. We will have to wait longer for the arrival of hybrid models and hydrogen as an energy generator. I hope you like this video. If yes, kindly click the like button and consider subscribing to my channel. And don't forget to smash the bell icon to get notified. See you in the next video. Thanks.